Hi everyone, I'm very happy to present you today SonicHoop using interactive sonification to support area hoop practices. This is in collaboration with my amazing co-authors Artem, Diemo, Emmanuel, Wendy, Michel and Frederic. So area hoops are circular hanging devices that are first introduced and popularized in circus artistic performance. Now area hoop classes are considered as special fitness programs and are offered in dance studios and gyms worldwide. The discipline sits between sports and arts and involves an essential instrument that can be augmented. We draw inspiration from the following areas: systems to support physical training in SIGCHI, interactive sonification in sports, interactive sound systems in digital music and performing arts, and interactive sensing technologies for large surfaces. I encourage you to see more details in the related work section in the paper. We used a participatory design approach that included area hoop practitioners throughout the process. We first conducted semi-structured interviews in a dance studio with area hoop students and teachers. We also discussed with Auditory staff at SIGCHI 2019 since they organized the live performance of area hoop. Based on this, we derived the 4 design goals, and involving hardware engineers and regular consulting to professional area hoop teachers, we translated these design goals into 4 engineering requirements and built SonicHoop prototype using capacitive touch sensing. Once again, I encourage you to see more details in the paper. So SonicHoop is an interactive area hoop that is enabled by 42 electrodes equally distributed over the hoop, and are connected to 4 Arduino MPR 1-to-1 capacitive touch sensors. We built an I2C communication protocol between Arduino sensors and the Batalino Riot, which streams raw sensor data every 15 milliseconds to a laptop using Wi-Fi. The raw sensor data, which is a list of 42 floats, is sent to a custom-made Max MSP program. We apply a moving average to smooth the raw sensor data and then use a step detection process to detect touch events and generate sound accordingly. We explored 3 sonification strategies, which are distinct from each other in terms of musical style and composition strategy. Sound Design Ambient divides the hoop into 4 sections, each of which produces a different type of dense, ambient sound corresponding to earth, wind, water, and birds. Sound Design Lounge divides the hoop into 10 vertical zones that switch to the music segment assigned to it. We use a music track in the jazzy lounge house style. Sound Design Electro Dance divides the hoop into 11 vertical zones and allows to layer 133 BPM loops in an energetic electronic dance music style. We evaluated the latency between body contact on the hoop and generated auditory feedback. The total latency is roughly 110 milliseconds. We also evaluated SonicHoop's sensitivity to different textiles as aerialist wears sports clothes during practice sessions or costumes for performances. We compared direct skin contact with 5 common textiles. To see how these different sonification strategies affect aerialists' perception and choreographic processes, we conducted a structured observation with 2 professional area hoop performers. Results show that regardless of sound design, SonicHoop improves participants' perceived movement quality. And depending on the sonification strategy, SonicHoop simultaneously alters participants' perception while performing and fundamentally changes their choreographic processes. Instead of translating music into movement, they search for bodily expressions to compose music. Future work includes exploring other sensing techniques and sonification strategies and testing them with more participants of different skill levels. We also plan to investigate interactive sonification in other acrobatic practices to further explore full-body vertical interaction. Thank you very much for your attention. I'd be happy to take questions.